Hi, my name is Massimo Mascaro. I'm with the Office of the CTO here at Google Cloud. I'm here today to talk about physical AI. What you're seeing here is a demo of a Boston Dynamics Spot robot that's been built by our partners at WPP. It's a big media company, and it's currently being rigged actually to film technical and commercial videos in high quality using a professional camera. This particular hardware is great for some of these robotic applications, and I'll kind of walk you through a little bit about it. This particular robot, fun fact, has been used to film the exact video that we presented yesterday at the keynote for our TPU V8 announcement. So what is physical AI? Let me walk you through some of the things actually we're doing that we think actually make Google Cloud really like a perfect platform for this kind of use cases. So first of all, as you can see in this slide, physical AI has to bridge actually the physical and the digital world. This is very, very important because training robots very often requires simulation. It's very hard to train a robot just in the real world. And actually building reliable simulations is crucial for these workloads. So you can actually go from a simulation to a reinforcement learning loop with actually kind of the help of Gen AI. And in particular, there are a number of things actually we can do with Gen AI to enhance the simulation and make the robot actually reduce the sim to real gap and be actually kind of better in the real world. We have a full stack of things. We have, of course, infrastructure and chips. I showcased the G4 machines. Of course, we have also TPUs and all sorts of other hardware that we can provide for this. And on top of that, we have a very, very robust platform for data and analytics in Google Cloud. Of course, we have research model. Google DeepMind Robotics is building sophisticated models for running robots, but there are also kind of many alternatives that we support from the open source and the NVIDIA ecosystem. And of course, we have platforms and agents and applications that we ship in Google Cloud. All this actually has an enterprise-ready foundation that has been refined over the years. Now, what this applies to physical AI is that, for example, you can actually have one of those robots go and scan a real environment and then use AI to help you rebuild from that scan of the environment an actual simulation where you then run the robot's training. This actually is particularly useful because those environments very often are complex and actually require also a lot of modification. Another aspect that is very important, of course, is using the robots in the real world. So I mentioned before the ability to run those agents as those robots as autonomous being. This is actually a video of the same Spot robot that I was mentioning before, recording our TPUs in our data center, autonomously moving in complex environments and doing this precise control task requires a lot of sophistications in these robotics applications. The general kind of picture that we have in mind, the general architecture that we have, is that there is a real to sim important component where you have to take those real environment and convert them into a digital environment where you run the simulation. The simulation has to run efficiently. Very often those robotic simulation requires millions of iterations. So running efficiently on efficient hardware like the G4 instances in Google Cloud is paramount. But then, of course, you have to augment those simulation to make to reduce the sim to real gap. And this is where actually Gen AI models like Nano Banana and VO actually shine a lot in terms of kind of bridging the gap. Then, of course, you have model tuning and training. You can use TPUs to do that. It's actually a great platform to basically have iteration very, very quickly across these different models. And then, of course, you have an inferencing and evaluation. In a simulation, the robot actually needs to behave as the model is trained. So you need to actually do inference in the simulation before you do it in the robot itself. And you repeat this loop many, many different times until the robot has the quality that you require. After that, you can then now deploy it in the real world. And we believe actually this particular ecosystem actually is going to grow. It's actually one of the edge of where Gen AI is going right now. We have a full physical AI portal that actually contains a lot more information than what I'm giving you here. And we're very happy to discuss with you customers your specific use case and help out actually collaborate and kind of make physical AI a reality.